Your reader who would like to read this paragraph. All right, thank you, miss. Go for it.
Okay. You have probably solved enough exponential growth problems by now to recognize that they involve growth in which the rate of change is proportional to the amount present. The more bacteria in the dish, the faster they multiply. The more radioactive material present, the faster it decays. The greater your bank account, assuming it earns compounded interest, the faster it grows.
Keep going.
The differential equation that describes this growth is dy over dt equals ky, where k is the constant growth, if positive, or the decay constant, if negative. You can solve this equation by separating the variables.
Okay. I don't understand. I do understand, but I don't know if you guys get how important this one equation is. It transcends over so many topics. All it says is saying that the amount that it grows is proportional by how much is present. And it transcends chemistry, it transcends physics, it transcends finance, how much money you make, depending on how, so that's why the rich get richer. The more money you have, the more money you make via interest. The more money you owe, the more money you're going to have to pay via interest. Isn't this so amazing? Because of this equation, this transcends a whole bunch of different subjects. We're about to solve it. You probably remember do you remember the formula PERT in algebra? Principle, P equals P e to the RT. Yeah. That comes from this right here. I remember it from PERT from the shampoo or whatever. So when I was a sophomore, that's how I remember PERT. PERT. Okay. Check this out. Look at this. So this is why we have that little blank space. We're gonna separate the variables to get an equation. Y equals something. So I'm gonna start with this. dy dt equals ky, and I'm gonna move the y to the left, and I'm gonna multiply by dt. So I'm gonna have this dy over y equals k dt. Are we okay so far? Now I am going to integrate. So the one on the left is just what? ln absolute value of y equals kt plus c.
Oh, yeah.
Are we still okay? Yeah, k is a constant. Yeah. That's because I got excited, so I'm like, Okay. I'm going to solve for y. E caret, the whole shebang. So I have absolute value of y equals e to the kt plus c. On the side note, x to the power m times x to the power n equals x to the power m plus n. So I have an exponent with a plus on it. So I'm going to rewrite it, and I want you to notice e to the kt times e to the c. And that's absolute value of y. Are we still okay?
Yes.
Okay, and I'm going to slow down. Yeah, it's a dot. This is just some constant. So we're going to let the situation determine whether the output is positive or negative. So that absolute value is going to go away. So I'm going to rewrite it like this. Y equals some constant e to the kt. And then let situation.
Attention YWA. We are going to secure the building at this time. Return to classrooms and offices now. Continue instruction and business as usual. Keep hallways clear. This is not a drill. Attention YWA. We are going to secure the building at this time. Return to classrooms and offices now. Continue instruction and business as usual. Keep hallways clear. This is not a drill.
Yeah, don't worry, guys. We're still fine. All right. Let situation determine positive or negative. That's the absolute value. And I'll put All right, guys, focus. We're still good. Don't worry. This is safe space. All right.
It's like they gave you a coordinate and the y was negative.
Yeah, like they give, like we're gonna determine. Okay. Yeah, you know what? Let's talk about it right now because we have it right here. All right, guys. So I kind of don't like this little part right here where it says the law of exponential change. All right, guys. So about this whole absolute value deal, like when do I put it? When do I not? I don't understand what's going on. The reason why e to the kt. Remember e? Okay, because there's so much stuff going in my brain right now. E to the x. Remember that expression looks like this. And then if I have y equals e to the negative x, that looks like this. Notice that it's always positive. You guys notice that? So this is growth. This is decay. I'm going to let the situation determine whether I have growth or whether I have decay. And notice, Chav, the absolute value of y, it's always above the x-axis. Yeah, but I could have a situation depending, I could have growth like this if you want to consider this growth. Or I could have something like, let's see. What did I do? Oh, okay. I could have something like that. That makes sense, guys?
Because you're like getting further away from the x-axis?
Yeah, like I'm moving further away from the x-axis, quote-unquote, growth, getting closer to the x-axis, quote-unquote, decay, you know, depending on the situation. But usually we're going to be talking about these right here. So my output's always going to be a positive y value, but the k value, because I know here it says if the k is positive, it's a constant, it's a growth. If the k is negative, it's a negative. That's because e to the x, you go like if it's positive, you're going to go in, further away from the x-axis, and e to the negative x, you're going to get closer and closer to the x-axis. It's like the growth and decay. No, k is like well, I guess it's kind of. I don't want to call it a slope because it's not. It's just your exponentials. The way exponential functions behave. You know what I mean? So they either behave like this or like this. So if and because e is a number bigger than 2, right? So if it's a number like 0.5 raised to the x, well then that one's going to look like that. But we're just going to always let the situation determine whether k is positive or negative.
Gotcha.
Okay. And don't worry, guys. I'm gonna help. So, should we do it right now? Okay, let's do this one right here. Do we have a volunteer that wants to read about radioactivity? All right. Hook us up.
All of it?
Yeah, all of it.
When an atom emits some of its mass as radiation, the remainder of the atom reforms to make an atom of some new element. This process of radiation change is radioactive decay, and an element whose atoms go spontaneously through this process is radioactive. Radioactive carbon-14 decays into nitrogen. Radium, through a number of intervening radioactive steps, decays into lead. Experiments have shown that at any given time, the rate at which radioactive elements decay, as measured by the number of nuclei that change per unit of time, is approximately proportional to the number of radioactive nuclei present. Thus, the decay of the radioactive element is described by the equation dy dt equals negative ky when k is greater than, or when k is positive?
Yeah, that's fine.
What is that?
If y not, the initial amount? Yeah.
Okay. If y not is the number of radioactive nuclei present at time 0, the number still present at any later time t will be y equals y naught e to the negative kt when k is positive. The half-life of a radioactive element is the time required for half of the radioactive nuclei present in a sample to decay. Example 7 shows the surprising fact that the half-life is a constant that depends only on the radioactive substance and not on the number of radioactive nuclei present in the sample. Okay, love it. You see this line right here? I don't know if you want to highlight it or underline it. Okay, right here. The half-life of a radioactive element, I can't even read. All that means is that dy dt equals ky. It grows or it decays by depending on how much is present, or k is just some constant. That's all it means. Cool, right? All right. And I know because I'm thinking of a former kid of mine. His name was Zachary Henry. Hello, Mr. Henry, if he's looking at my video right now. As soon as he saw this, he would just go y equals y naught e to the kt immediately as soon as he sees that.
You don't know. That's kind of robotic a little bit. Don't worry. I'm not talking smack, Mr. Henry. I'm just, remember our conversations we would always have on this. You can always do this if you want. Every time you read that, and you are safe. But I want you to not be a robot, and you'll see what I mean when we do the WASP problem. So, anyways, let's look at example 7 and let's figure this one out. Find the half-life of radioactive substance with a decay equation. Okay, I already know it decays. There's no need. Remember we told you that let the situation determine whether K is positive or negative? So let's rewrite this as y naught e to the kt and show that the half-life depends only on K. We're letting the situation determine whether K is positive or negative. I know it's decaying, so that's why they put the negative in there, but erase it. Yeah, I'm going to put let situation determine whether K is positive or negative. That way there's no thinking involved. Okay, you guys ready?
Yep.
All right. They want us to show that when I find my half-life, that K is not, that the only thing that bothers it is just K. That's it. Remember that formula that I showed you earlier to write down? That's what I want to get to. And then we're going to see if we can. So here's my formula. Y equals y naught e to the kt. And if I want to solve for half-life, that means that I have half of the amount originally present. Yes or no?
Yes.
So I'm going to call this 1/2 y naught. And then I'm going to put a subscript of 1/2 on the bottom of that t. So that's t to the 1/2.
Why would you where did it not?
Okay.
Oh, I'm talking about the t part.
Yeah, let's answer all questions. So this is like initial amount. So if this is my initial amount, this means I have half of initial amount. Let's see. Now the next question, Wilson. What was the question? Where did I?
Why would you put the 1 subscript 1/2 on the t?
Good question. Because this time that I'm going to solve for is my half-life equation. Because I put a half here, so whatever value I get, t of 1/2, this is my half-life. That's how long it takes for half of this amount to decay.
Oh, because you're looking for time.
Correct. I'm solving for my half-life time.
Okay.
Does that make sense?
Yeah.
Okay, so here's the situation. We have to solve for my half-life, for the t 1/2. So the first thing I'm going to do, I'm going to divide by y naught on both of them. And if I divide by y naught, they just cancel out. Do you guys see that? So now I have 1/2 equals e to the kt to the 1/2. Not to the 1/2, t subscript 1/2. Are we still okay?
Yes.
How do I bring the kt to the kt half? I keep saying to the 1/2. Kt subscript half down. Yeah, ln. You can use log as well, but we're going to use ln. So whatever I do to one side, I do to the other. And I'm using ln because ln of e is 1. Bring this down. Down right here. And here's what I now have. I have ln of 1/2 equals kt to the 1/2. And then I guess I'll show the ln of e. Yeah, subscript half, not raised to the 1/2. Man, I keep doing that. ln of e is just 1. So now I have, let's see, ln half equals kt subscript half. Are we still okay?
Yep.
All I got to do is, I got to solve for t subscript half. All I got to do is divide by K. And I know what you're thinking, because I don't remember seeing the 1/2 on there. You're saying, Chav, the picture I have or the notes I just have don't have a 1/2. Okay, well, let's make it look like 1/2. The numerator, ln of 1/2, is the same thing as saying ln of 1 minus ln of 2. Oh, no wonder they put the negative there, because they didn't want to see the negative. Okay, are we still okay? Okay, so ours is going to differ a little bit with the formula with a negative, because we're letting the situation determine what K is. So here it is. T to the 1/2, the T half subscript equals, what's ln of 1? 0. So it's going to equal negative ln of 2 over k. Now go look at that formula that you wrote earlier. It's probably not going to have the negative. It'll just probably have ln of 2 divided by some constant. Divided by some constant? Okay, that's fine. Remember, make sure that you put this in there somewhere, that we're letting the situation determine whether k is positive or negative. Cool or not cool? Okay. Having said that, we're going to skip one example so we can use this immediately because right now it's fresh in your head. So go to the last page. All right. No, don't worry. Look, yeah, you can't go anywhere. All right. Example 9. Check this out, guys. So this is a legit question that you would probably have in a chemistry class, a freshman chemistry class, because this is not graduate level, I don't think. Scientists has used carbon-14 dating, used 5,700 years for its half-life. It's true. You can go to a Google, and this is how they determine like how old fossils are. Like, you know, that's how they find the age of a sample in which 10% of the radioactive nuclei originally present have decayed. Okay, if 10% have decayed, that means how much do I have present? So put 90% present. All right, I already know T half equals 5,700 years. So I know, let's see, what do we know? What did we find out right now? T half ln of 2 divided. Okay, got it. So we know that I can get my k value by doing ln of 2 negative divided by t half. And how do I know that? Child, how do we know that? Because a little while ago we did t half equals negative ln of 2 divided by k. So from that we got that equation. Right? And because I know that the amount present equals my initial amount, e to the kt, I can just go right into this. I can say 0.9 of the initial amount equals initial amount, e, and then what k value? This k value. Should I put a subscript? No, that's fine. K, and then t. Are we okay? Trav, I don't understand what we're doing. We're solving for t. And we're going to go slow. Yes, I need a k value first. Does everyone have a calculator? All right. In your calculator, you're going to go, we need our k value first. So you're going to do this first. Negative ln of 2 divided by 5,700. Negative ln of 2 divided by 5700. Enter. I got this number. Store it alpha k. All right, guys, focus, because this is pretty hardcore. All right, real quick, because I want to make sure that you know. K equals negative 1 point, and I already forgot. 2160 times 10 to the negative 4. That's what that e to the negative 4 means, guys. So what does that mean? Negative 0.000121160. That's what it means. Dot, dot, dot. Keeps going forever. Are we okay so far? Nothing crazy, right? So you can see that my value is negative, so that means it's decaying, so we're good. And what do we want to solve for? T. So here we go. I'm going to divide. Oh, before we start, does everyone understand this equation here? 0.9 because of 90%. Right? Okay. The y naughts cancel out. So 0.9 equals e to the kt. And then what do I do to bring the kt down? ln. So whatever you do to one side, you do to the other. So now I'm going to have ln of 0.9 equals kt. And then how do I get the t by itself? Divide by k. So you're going to take your calculator And you're going to go ln of 0.9 divided by that k value that you have. It should be several hundred years. So let's see, ln 0.9 divided by alpha k. That's how long it takes. 866.4176. 866.4176. And I need units.
Years.
Look how many years it takes just for 10% to be gone.
That's
Isn't that like, well, I mean, you know, it's hazardous. That's why radioactive material is dangerous because, yeah. Isn't that cool?
That's cool, but not cool.
Yeah.
It's cool but scary. It's interesting.
All right. Check this out, guys. So hopefully this next example is going to put it all together. And here's where, yeah. Choosing a base. All right. So check it out. Ready? At the beginning of the summer, the population of hive of bald-faced hornets, which are actually wasps. Did you guys know that? That bald-faced hornets are wasps? Yeah, I didn't know that. Now I know. Is growing at a rate proportional to the population. Underline that right there, guys. Growing at a rate proportional to the population. That means this. dy dt equals ky. From a population of 10 on May 1st, the numbers of hornets grows to 50 in the 30 days. If the growth continues to follow the same model, how many days after May 1st will the population reach 100? Okay, so here's what I have. Population of 10 so my initial population is 10, and my population after how many days? 30 is 50. If you are like Mr. Henry, as soon as he saw this, he would say, and I'm going to show you how to do it two ways. He would say, immediately after that, he would go, y equals y naught e to the kt. And I don't care what it says. It says choosing a base. I don't care what it says. I'm going to use the base of e. And he would say, okay, well, the initial amount is 10, so that's my y naught. 10, e, and kt. And then I know that after how many days? 30 days. So I'm going to write t equals 30. And I know that after t equals 30, I had 50 hornets. So what he's doing is solving for k. So if t equals 30, I need, let's see, what do I need? I need k. So then he would do this. 50 equals 10 e to the 30k. So I'm going to go solve for k. So I'm going to get a k value first. It's going to be a positive number because it's growing. So what do I do to solve for k? I got to divide what first? By 10, divide by 10. What's 50 divided by 10? 5 equals e to the 30k. Now how do I bring the 30k down? So I'm going to go ln and then ln. And then ln of 5 equals 30k. And then how do I get k by itself? Divide by 30, divide by 30. So this is going to give me my k value. K equals ln of 5 divided by 30, which equals, take your calculator. Try it out, guys. Ln of 5 divided by 30. And you get some number. 0.05. Hook me up with digits. And I'm going to store it to k. Unless you want to use a different letter. It doesn't matter to me. Store alpha k. Are we okay so far? All right. So then Henry goes, all right, I got my equation. Y equals 10 e to the kt. And what is the question asking for? How long did it take for it to reach how many? 100. So I'm just going to go 100 equals 10 e. And this k is this k. And then t. And I'm just going to solve for t now. Solve for t. Are we still okay?
Yeah.
All right. How do I solve for t? What do I got to do first? Divide by 10. What's 100 divided by 10? So 10 equals e to the kt. Then how do I bring the kt down? ln, ln, ln. Then kt comes down. So then I have ln of 10 equals kt. And then I already have k saved in my calculator. So all I got to do is divide by k. T equals ln of 10 divided by k, which equals, I'm going to take my calculator, ln 10 divided by alpha k. 42.920. 42.920 days. And everything's okay. It's perfect. You can do it like this all the time. But this could have been way simpler. Yeah.
My God.
No, yeah, like I said, that was pretty simple. That was pretty simple, right? A lot of steps. Okay, check it out. Check it out. As long as you know that it behaves like this, it's going to be an exponential function. It has to. I can choose whatever base, and I bet you, well, not whatever base. I can choose a specific base as long as the numbers are pretty, and I bet you I will get this exact answer. Chav, how? Okay, let's start over. I'm going to change my colors to like sky blue. I'll use all that space. I won't need it though. All right, here we go. Y0 is 10, and Y of 30 is 50. So I can say this. I can say, okay, well, let's see. I need a something times something. So I'm going to write, I'm going to choose the base to be 5. All right, check it out. Well, you know what? Let me slow down so I can tell you what I'm thinking. No. Well, okay. It's because I need a relationship between 10 and 50. If it was 25, then yeah, maybe 20. We'll see what's up. All right, guys, focus. How do I get 50 from 10? Times 5. So I'm going to say my base is 5. And I already know that the time is 30, right? So that means K better be 1 over 30. So I'm going to write KT. So bear with me here. 5 to the power KT. And then I'm going to say, if I use K as 1 over 30 and T is 30, do I get 50? Well, not yet, because I need to have initial amount. 10 times. There we go. This is my initial amount. Okay. Initial. That's like your Y naught E to the KT, where E is my base, and E is the 5. Or like E is a base, but E's a number. So now I have 10 times 5 to the KT. If I use this, do I get a 50 at 30? I don't know. Let's find out, Chop. 10 times 5, K is 1 over 30 times 30. And then look, 1 over 30 times 30, that's just 1. 5 to the power 1, that's 5. 10 times 5, that's 50. It works. Check mark. Works for T equals 30. Yes. Yes, I had to derive that.
Where did you do that?
All right. Sorry, guys. In my brain, it's going so fast. I already know that T equals 30. No. Stop. If T equals 30, I need this exponent to be a 1 because 10 times 5 is 50. So the only way that I can get the exponent to be a 1 is if K is the reciprocal of time.
30 over 30 would give you 1.
Yes. Does that make sense? I'll put it right here. I need 5 to... There it is. So let me explain it with math. I need 5 to the power x to equal 5, comma, take reciprocal of time to make product, parenthesis, K times T, equal to 1. To make product equal to 1. Hopefully those instructions sound better now. Yeah, take reciprocal of time to make product K times T equal to 1. Are we better now? Okay. So here's what I'm saying that I can use my equation. I know, here's the moment of truth. I can say that my equation is this. 10 times 5 to the K over K times T. So K is 1 over 30. So I can say T over 30. 1 over 30 times time. Mm-hmm. And now, what did they want me to approximate? To approximate when I have how many bees or wasps? We have 100. Equal this to 100. So, what do I do to solve for t? Divide by 10 first. Check it out, guys. We're almost done. Divide by 10. So then we have this. 100 divided by 10 is 10 equals 5 to the t over 30. How do I get the t over 30 down? ln. So I put an ln on both sides. ln. And then look what I have now. I have ln of 10 equals t over 30 ln of 5. Now I want to get t by itself. So I'm going to divide by ln of 5 and multiply by 30. So I'm going to write it over here. T equals, let's see, 30 ln 10 divided by ln 5. Like, guys, I am not fake. If I am, then that would, no, I'm not fake. If I type this into the calculator, look how amazing this is. I haven't done this yet. I've done it in years past. There's a brand new, I haven't done this yet. It should be digit per digit the same as the answer we got. Are you guys ready? I'm going to try it out right now. Alpha y equals, child, what answer are you talking about? It should be the same as this one. What was it? 30 ln 10 divided by, oh man, I'm a little nervous. No, I'm not nervous. I know it's going to be the exact same. Look at that. We got the exact same answer with a different base. If you are slightly confused, all right, guys, real quick, because we're pretty much done. If you are slightly confused, you can pull up Mr. Zachary Henry, and always, as soon as you see that, like, I'm just going to use this forever. I don't care. I'm just going to solve for K by hand. I'm going to force the base to be E, and I'm going to do. Will you get the answer? Yes. Do you have to use e to the kt? No, as long as you have an exponential and you know like how it grows. Cool or not cool? Cool. You now know enough. You now know 97% of AB